Hello, everyone. Welcome to the EAU, ESUT, and ULIS course. It's a basis urology program, which is mainly aimed for residents and young urologists. And today's program is about awareness of Uro today and technological future. I've got with me Professor Andreas Kolarikos, who's going to moderate with me. And we have got four speakers, Dr. Tiley, Professor Rasweiler, Dr. Pietropaolo, and Dr. Enikiv. And I think we should give the floor to Dr. Tiley to start his presentation. And once he finishes the presentation, we will have time for a couple of questions, but keep your questions coming in the Q&A and we'll try and answer it there. But also, if there is a recurring thing, we'll ask Dr. Tiley. Thomas, the floor is yours. Thank you.
Thank you so much, Bhaskar, and thank you so much for the invitation to give a talk here on the CSU course. Let's get started. So I'm going to give a talk on single and reusable ureteroscopes and a tech update on that. These are my affiliations. I'm in EAU and ESUT, as well as in Tower from the Endo Society, and our hospital is a member of the EUROGen. These are my conflicts of interest. And let's get right to it. So what is currently on the market for reusable flexible ureteroscopes? And there's a lot of them. There are reusable flexible ureteroscopes. You have analog and digital. You have different measures and designs going from a 7.5 French to a 9.9 French scope. And it's very important to have an idea of these different characteristics of your scope before you purchase one and before you use it. For instance, the smallest tip size is from URFP 6 or 7 from Olympus, but the smallest shaft size is from the Flex X2 or X2S from Storz. And that does make a difference because it often does happen that you can't enter a scope with an 8.5 French scope, but you can enter the ureter with a 7.5 French scope. So the 7.5 is very useful for thin ureters or for kids. Another difference between different scopes is the tip anatomy, the tip design. For instance, the Storz scopes are just very blunt. And this is from a URF P6 or P7, where you see that the tip itself is 4 point something, and you have these edges that are off that theoretically may help you enter the ureter a little easier. This is the newest URF P7, I think. Another important thing is that there's one scope that has a dual working channel. And it's very obvious that if there's one complete empty working channel, that you have a better flow. Some other differences is that the working channel may be at different positions like 2, 3, 6, or 9. And the question is whether or not it matters. Does it really matter whether or not your laser fiber comes out at 3 or 9? In my opinion, I don't really think so, because for instance, if you see in this video, this is my, I have a Storz scope. It's a Flex XC. And I was looking at the stone, and the tissue here was hindering me for treating the stone. So what do? I just flip my scope upside down 180 degrees. And all of a sudden, all the calyces will be on the other side, and the stone will be on the other side as well. So I flip the scope upside down. There's my laser fiber still at the 3 o'clock position. And I go towards the stone. And instead of flipping or using a scope with the working channel on the other side, you just flip the stone to the other side. Theoretically, having a 9 o'clock position working channel may be more useful for treating left-sided kidneys and a 3 o'clock position for right-sided kidneys. But like you see, just flipping the scope may help you with that. It's not necessary to have 8 different kinds of scopes in your hospital. If you have them, that's awesome though. Another important part of your scope is the very distal part. And this is a very nice paper by the group of Oliver Traxler, where they looked at the reachability of a very dependent calyx. And the distal tip of all these digital scopes, they were not able to reach that very dependent calyx except for one scope. And the reason is that a lot of the chip is in that distal part, the distal 1 centimeter, and that is not flexible in all these other scopes. And if you look at analog scopes, you're able to reach that calyx with most flexible scopes though. Once again, that's because you don't have the chip on the distal part of your scope. That helps in reaching difficult positions, as demonstrated here clinically by by a group by Mitch Humphreys in 2008 already. Additionally, analog scope may be just a little bit thinner, which means that they less need an access sheet to enter the ureter. Image quality, there's really not much of a debate here. It goes without saying that a digital scope has a better image quality than an analog scope, and I don't need you to guess which one is the analog scope and which is the digital. So that really helps a lot if you have a digital scope available, especially if you're treating upper urinary tract urothelial cancer. How heavy is your scope and how ergonomic is it to use it? And that's very important as well, because if you're an endourologist and you're doing 10, 15 flexible ureteroscopes a week, you have to have something that's very ergonomic. And a lighter scope is very important there. This year in this video, you see a LithoVue disposable scope, which is very light. But the weight of your scope is very important. And digital scopes are somewhat lighter than an analog scope that has the light cable attached and the camera attached. And this is shown in this ergonomics paper as well, that a digital scope uses less workload than an analog scope. And then if you put two and two together, if you have a better image quality, a lower weight scope, and more ergonomic use, you're probably somewhat faster. And indeed, one of our chairs here, Bhaskar Somani and Dr. Binbai, have demonstrated that if you use a digital instead of an analog scope, you shave off 10 minutes of your procedure. And that is very important information. Something very new here, and that's been published quite recently, our scopes go up and they go down, and then you have to rotate to reach the Cayley sheets. But why only two positions? Why only up and down? So this is a scope that was very recently produced, manufactured by Olympus. And this is a scope that has kind of like a joystick, like a Game Boy joystick handle to move your scope not only up and down, but also left and right. And they demonstrated that they were able to complete the tasks somewhat faster, actually significantly faster than a regular URFP6. Mind you, this is an analog scope. And I wonder whether or not it would have made the same difference in comparison to a digital scope, now that we've seen that a digital scope can help you produce a task faster. Nonetheless, this is quite interesting. So if reusable scopes are that good, why do we need disposable scopes? Well, reusable scopes have a limited lifespan. Disposables are always available. You don't need to wait for sterilization. It has optimal flexion each time. And if it breaks, it breaks. So you don't care to put maximum strain on it, which you do on a reusable scope. And like everybody will tell you, maintaining a flexible ureteroscope program with reusable scopes is costly. And if you always use a disposable scope, it's a very predictable cost. You don't have any strange costs. All of a sudden, the scope breaks and it's 11,000 euros instead of always paying the same cost for one scope. And what about single-use scopes on the market? Well, there's plenty of them, and those are only the ones that I could fit on the screen, really. But are they any good? You can see 1, 2, 3, 4, 5, 6, 7, 8 of them, and there's definitely more still entering the market. But are they any good? And let's look at the characteristics of these scopes. They all are quite light. Most of them have a shaft size between 8.6 and 9.5. Tip size quite similar as well. All have a working channel of 3.6, except for the Xiaogang UCare scope that has the biggest working channel. And obviously, it then has the better irrigation, as is demonstrated here. They all have bidirectional deflection between 270 and 280 degrees, and they're all digital. So on paper, they're all comparable, but are they really? Because there's a difference in build quality, durability, and handling, and image quality. So they've been compared multiple times by multiple groups in multiple different settings, both on benchtop and clinically. And the ones that have been tested most are the LithoVue from Boston Scientific, the Putin scope, and the Axis from Dornier, which is actually a Chinese scope that is marketed by Dornier in the United States. It's actually from Anjin. And those are the three most tested scopes, and they have comparable results. Maybe the Axis has a little better image quality, but it's probably clinically not that relevantly different. So how do they compare to reusable scopes? Well, optically, according to handling and ergonomics, and clinically, again, they're quite comparable to reusable scopes. So why are we using reusable scopes that come with a lot of cost instead of disposable scopes? Why not switch altogether? And there's several groups that looked at the cost, because this is what's really driving the difference between, because they're comparable in all other aspects. And they see that, well, there's quite a difference here. Here, the disposable exceeds the cost of reusable after 61 procedures, 99 procedures. In this group from California, the costs were quite similar. So if you look at all these papers, what it comes down to is that the cost-benefit analysis is really country, surgeon, and center specific. How much does a reprocessing cost? What's your contract with your hospital and the manufacturer, and so on. So if you want to see whether or not you need to do a disposable or reusable or hybrid system, analyze your own costs to identify the potential benefit of going to reusable. Or do you need to have both? Do you need to have disposable and reusable, like a hybrid model? And then you can use your reusable scope, your disposable scope, for cases in which you think that the reusable scope may undergo a lot of strain, like a lot of stone burden, having a lower pole stone, a steep infundibulopelvic angle, using an access sheet, because that puts a lot of strain on your scope as well, or it can damage your scope. And this is one piece of data from a group that looked at whether or not using hybrid is cost efficient. And he actually had cost savings after about 230 cases, where they applied this strategy of using disposable scopes for larger stones, lower pole stones, and stones in a steep infundibulopelvic angle. So with a colleague of mine, we developed a cost efficiency formula, and this is really the formula itself. And if I look at it, it's just very complicated, but let me put that into some visual aids. The only things you need are your repair costs, the cost of a single-use scope, and the average usages that you have before needing a repair, as well as your repair costs. And you can put all of these in an Excel file, and then it spits out how many more uses you should be able to get out of a reusable scope to be cost neutral when using a disposable scope in, let's say, 15% of the cases. And we put this in a graph here. And if you use a Fusion scope at 650 euros per case, you would need to have 28% more cases from your reusable scope, considering you use 23 cases before repair without using disposable scopes. But if you have a more expensive scope like the LithoView, you need to have an increase of use with the reusable scope of 74%, and that may not be that easy to reach. Interestingly, very recently published by Oliver Traxler's group, they definitely demonstrated that using a disposable scope does indeed increase the lifespan of your reusable scope, as we have anticipated with the model. And it's interesting to see that the increase really only starts after using your reusable scope for 15% of the cases or more. And they went from 35 cases to 49 cases per scope before needing repair. One very important piece of information is that they have a high level disinfection and not the very strict 3-hour taxing re-sterilization process that some other hospitals have. So what does the future hold for us for reusable and disposable scopes? And in the blue circle, you see what's already here. We have a durable shaft, a small shaft size, the 7.5 French in reusable and disposable, large working channels or dual working channels, and improved optics and visions. The current digital scopes are amazing. But what is not here yet, and what can we expect? A temperature sensor? Maybe with the high power lasers that may be useful. Wireless connectivity. Who doesn't hate that cable on your scope? A second working channel, if necessary, maybe just a larger working channel. Pressure channel, and so on. AI, this is really something that is up and coming. Interestingly, the pressure sensor, we don't have to wait for that anymore. It's coming for sure, because if you look on the internet for patents, and mind you, there's a billion patents out there, so it's like finding a needle in a haystack, but this is what I found. This one was published in 2018 under the name of Boston Scientific, and they entered a patent for a disposable scope with a pressure sensor. So this patent has been out there for a while, and I think we can expect this on the market soon. Something else that the group of Clayman has worked on is a female ureteroscope with a shorter shaft instead of a 65 centimeter shaft. And they demonstrated in a benchtop, however, that you have a 11% more flow, which is significantly more than a 65 centimeter scope. But whether or not that's clinically relevant is still to be seen. And this was a 65 versus 45 centimeter axis disposable scope. What else does the future hold? Well, it's a competitive market. And I think the cost for reprocessing and repairing a reusable scope and the purchase of a reusable scope will probably go down with more disposable scopes entering the market. Also, the cost of disposables are going down as well. It's very interesting to see that both Wolf, Olympus, and Storz, and probably Storz will be first with this, are going to manufacture disposable scopes. And we do see that the cost of one disposable scope is going down, whereas the LithoVue, the first on the market in 2015, is still about 900 euros without taxes. And there's the cheapest scope currently in Belgium to find is L scope at 450, which is about half. And like we've seen, they're quite comparable. So in conclusion, consider specific ureteroscopy or ureteroscope characteristics before purchasing and using them. Reusable scopes have a limited lifespan. We all know that and are considered costly, but it's very important to consider your own cost before considering what is more cost efficient. And cost benefit really depends on the number of usages before repair and the cost of a disposable scope, which can really vary quite a bit. Disposable scopes appear to be comparable both in characteristics and clinically to reusable scopes. And considering a hybrid model may be the most cost efficient for a flexible ureteroscopy program. And like we've seen, the market is evolving fast. And I think there's definitely some very interesting things coming up in this or next year. Thank you. Any questions?
Thank you, Thomas, for really an excellent presentation. But the aim of this meeting today is I'm a resident.
Okay.
I'm a young urologist now. So a lot of piece of information that you have given me. But give me your own perspectives. You cannot buy everything. I mean, this is... No. Tell me, how should I choose a couple of digitals or a couple of, I don't want the brand names, a couple of disposables? And that's the first part of the question. I mean, give me your clues, what exactly you want in your everyday practice. And you have explained it, but I've seen in the current practice that disposables are everywhere. And actually, no one cares about the cost. And I would like a comment. Why do you think urologists adapted disposables so quickly?
Well, both very good questions. What I want in my practice is a scope that is durable, ergonomic, so that I don't have a hurting arm at the end of the day, and reaches the calyx if I need to reach it. And there's some very interesting benchtop studies that have been performed, like the one that I showed, reaching the most dependent calyx. And that for me is the most important. I need one very good scope, and I'll buy multiple of those. But you also need a scope, I think, to treat children. There's one very good analog scope that's 7.5, but the image quality of that is not perfect to treat, let's say, upper urinary tract stones. And even for upper urinary tract cancer, and even for stones, I prefer digital over analog. Whatever you do with your scope, be gentle to it so that the durability really reaches as far as you can. Talk with your sterilization team and make sure that they know what they're dealing with. And if you consider all that, you don't need 7 or 8 different scopes. You just need one very good scope. For digital scopes, I think it's the same thing. You don't need a lot of different digital scopes. You need one good one that has a good working channel, good flexibility, good image quality. And I like the 7.5. There's only one brand that has it right now, but it's a very good scope. It has very good image quality. It's sometimes a little jittery on the handle, which you don't have on a scope that is slightly thicker. But the 7.5 is really so important because then you can really apply it every single time. So that's one important part. And then why people have adopted it so fast, I think because all of these things that I just said about scopes needing repairs, you just need to be gentle with your scope. And if you consider that and talk with everybody that touches your scope, you can really increase your lifespan of your scope. And then it's not that costly anymore.
Okay. Professor Somani, Bhaskar?
I think Jens had a comment. Jens, you wanted to comment?
Yep.
Professor Rossweiler.
I can make just a comment as an experienced, or let's say as a chief of a department, not as a resident, because the residents wants to do the treatment. That's clear. And they want to get the experience. But I'm responsible for the cost, and I can tell you with the hybrid model, we were able really to put our costs down by 150,000 euros a year, because we did not have the repairs anymore. And the problem is, of course, if you are in a private practice, you can have your own scope and you take care of it as a reusable one. But as long as you are working in a big department, you have multiple people. And it's not only this, it's also the quality. Sometimes they are coming back from the sterilization.
Absolutely.
Absolutely.
Leakage with a leakage. We tested before, everything was tight, and after sterilization, we have a leakage in the channel. And
completely agree.
These are the problems. And so I think the hybrid model is a good solution. We heard about the comment on ecology. I think we have to accept some things in this regard. We have disposable laparoscopic instruments and so on, robotic instruments. So I think this is not the problem, but I guess it has a real impact. I think the hybrid model is the best way to go.
Fully agree. Couldn't agree more.
Thank you very much, Jens.
Should we go on?
Yeah, one quick question, Thomas.
Yes, please.
Single line. You have tech and you have cost, and there is a balance. Would you, I mean, for lots of our young residents, what is more important, to have it cheaper, more of it, or technologically advanced and less of it? What is your take, quickly?
Could you repeat that? So
you have technological, you have cost effective, but not so technological advanced scope, or very advanced scope, but then it racks up the cost. Where is the balance? Because technology is a lot of it is surgeon dependent as well, I guess. You can somehow. Yeah. Okay.
I mean, you can do the exact same thing with an analog scope in comparison to a digital scope. That's been demonstrated. It only takes you a little longer. So cheap with less tech.
Okay, thanks. Over to you. Over to you, Andreas, and then you.
That's all right. That's all right. Professor Rossweiler, Thomas showed us a slide about the ergonomics. So please guide us through the ergonomics of the ureteroscopy, because I think it's very important for ourselves, for the surgeons.
For me? Question for me?
No. It's for Professor Survival.
No, it's for the next talk, for Jens' talk.
Professor Rossweiler, please go on. Yep.
So you see everything. I think it's very interesting. The talk of Dr. Tailly basically was talking about all the problems that we find, but I want also focus a little bit on the surgeon, and of course then maybe we can increase the quality. So we have a new armamentarium for flexible URS or retrograde intrarenal surgery. We heard about the scopes and the modern imaging. But also, I think the access sheaths have come in a better way. Clayman is thinking about to measure the pressure of insertion as a new tool. We have laser fibers, baskets, and guide wires, and particularly laser devices, I think, which is very important. But nevertheless, we have some problems, or yes, with the classic handheld ureteroscopy. We heard about the weight of the handle of the instruments. So you need 3 hands. You need a control of the scope at the meatus. You need, because there you have to fix it. And you see this is from Olivier Traxé. And then you have to rotate and deflect the scope. And finally, you need, these are your 2 hands, and you need another hand, a third hand, to insert a laser fiber or a basket. So that's where you have to be a team. And then maybe you can have at least 2 or 3 feet that you need. You need one to control the fluoroscopy. The other one, I think this is very important, to activate the laser, and some types of instruments are really to activate the irrigation. Of course, this can be probably done also with a device that provides the irrigation. You see here the working of the 3 hands with a disposable scope here in this time. And of course, this cannot be always a very ergonomic working position. You have a few space for the surgeon and the assistants, and of course a low stability when handheld. And so particularly when you have to extract fragments or so, I think it's really a nice work together, but you see this might be a problem. And of course you can improve the ergonomics, in my view, by a sitting position, because you can stabilize the elbow. This is at our lithoscope. You have then thereby you allow more space for the assistant who could be standing in this time. And of course, also, if you sit, you have an easy use of a foot pedal, let's say for activation of the laser device. I think this is one way to improve the ergonomics. Another way, and this I found, not our video, this is one of the videos you can find by Maestro. And you see in the back, there is, of course, the technician, the radio technician, who is then moving the X-ray. This is when you're using a C-arm, and he is taking care of also the activation of the fluoroscopy, which I must say, it's not what I like. So we are activating the fluoroscopy usually on our own. But of course, this is a way to overcome some of these problems. And then we heard about the design of devices. For example, Boston has the LithoView Empower that you can use a single hand also for activation and advancement of a basket or a laser fiber, just with this handle that you can plug on. So this, I think, is a good idea. Theoretically, this could be also done with a reusable device. Of course, at the moment, you can only use it for a single-use device. This is a very, very interesting thing that comes on the market, and this comes from Wolf. This is their first reusable, semi-rigid, flexible ureteroscope. And the interesting thing is that it has a different handle now. So you will see how you can use it in the future, and at the end of the handles, we can insert it. And it has a rigid part and then flexible tip, which probably might be very useful, of course. I have seen this only on an experimental basis. This is device is done in Munich by the department rechts der ISA, and Dr. Straub is working on this very interestingly, and we will hear of this probably in the future. But of course, we know that we are using our Da Vinci every day from the console, and imagine you could do this yes, with robot-assisted flexible uroscopy. And I can tell you that this is working very nicely by different surgeons in my department since 2015. And this is the Avicenna RoboFlex that we are using, and we have bought it. So therefore, I don't have any financial problems with this at the moment, because we bought the device initially. Of course, we were involved in a little bit of the development, and you have this card with an adjustable height, rotation, forward, backward, sterile coverage. And then you have 4 or 5 different arms where you can exchange the manipulator for a reusable device, Pusen and lithoscope, and also for the 3 main digital flexible devices, reusable devices and disposable devices. And here you see it, how you put it in. This time it's a reusable storage device that you heard about it, and you fix it there, and the whole thing takes really some minutes. So you can, when you prepare the patient, you insert the access sheath. In the meantime, this can be prepared, so it doesn't take a long time. It's not like with a Da Vinci device. Here is the laser system that also can put in, and you can control the laser fiber via this system directly from the console. And I guess this is also important. So all what we said, you don't need to have something extra. And I guess this is very important. So you have here the console with an electric brake and armrests, big monitor, and I show you on a big screen. So here you see it in the right hand, you have this magic wheel that can really transform the flexation of the instrument in a real low degree. Everything is displayed, the kind of rotation, the kind of deflection, and of course, the position of the laser fiber, of the instrument when you start, when you're coming out the access sheath. Of course, you could use it also without access sheath, but I must say we routinely use it with the access sheath, and then everything is here displayed, and then you can really use it. So additionally, you have a kind of 2 pedals integrated in the seat, and therefore outside, for example, here you can place your connectable manipulator for foot pedals of a laser or X-ray machine. I must say, we don't use this routinely. We just place this device, whatever we have. We are now very fascinated about the thulium laser, but we put it right beside the console so that you can use it there. And here's the irrigation pump. I think this is very, very important. You have different types of degrees of irrigation. You have an excess flow where you could, a peak flow that you can flush. And all these things, I think, are very important and are very helpful during the procedure. So here you see less than 4 minutes, about 4 minutes, with the 2 stabilators with the access sheath in place. And then we just insert then the instrument as you've seen it before. When it's already put in here, you see it once again, that's I showed you before. And then it's inserted. And here is one of my co-workers, Dr. Scheidlin, who works with the device, and you see him very nicely working here. And of course, we know about the techniques of lithotripsy, dusting, chipping, popcorn, jacuzzi, or fragmenting. And I just showed you here where you can nicely use either the inspiration, expiration, respiratory movement of the patient, or you can slightly dust the stone, and you can really meander the stone here with the device. And here you see the device working when we were fragmenting a bigger stone. This was a stone at the UPJ, and you see this is how it works a little bit. You can stabilize it by the assistant sometimes. This is the jacuzzi effect or popcorn effect. I think physiologically or physically you should call it a jacuzzi whirlpool effect, because it's not popcorning, but it's really well known from this device. And on the left side, you see the display. You know, this shows you exactly where you are with your instrument with respect to the kidney. And then, of course, you know at about 50 or 48, whatever, you have to see this, when the access sheath can be expected. And this is very important for fragment extraction, because then you know exactly when you go back, and I show this here, you go back, you know this comes down, and then I know now at a certain level comes the sheath, and then I have to be careful, a little slower. This is very important if you have bigger stones, because then we know exactly now comes the sheath, you see, and that's also very, very helpful during our daily work. Here you see once again, the good thing is, of course, and I think this is a major advantage, that you separate the assistant at the bedside from the surgeon at the console. So the assistant can work very easily here and activate, for example, here this N-gauge for fragment extraction, and you help him to guide it. And then once this is done, you go back and bring it out. So in conclusion, I must say there are recent developments to improve ergonomics of flexible ureteroscopy, as I've shown. Probably also new instruments. I guess this is very important. In my view, anyway, the best alternative represents the robotic flexible ureteroscopy, because it really provides superhuman movements, particularly rotation and the degree of deflection, and really you can really fine-tune this, and it separates the assistant from the surgeon. And for us, I must say, it provides the possibility to treat larger kidney stones transureterally with lower trauma to the kidney, and of course also to the instrument, because of course the instrument is also, we discussed this, better use, but nevertheless, I must say we need to have this hybrid way of using both reusable and disposable scopes. But this comes now really in a range that the PCNL plays a minor role. Mini PCNL we don't use anymore. There is a little problem. The reimbursement for PCNL in Germany is much better than for flexible ureteroscopy, but we don't care. I must say we are really in favor of the device, and therefore we are doing this. Thank you very much.
Thank you so much, Jens. That was a wonderful presentation on robotic flexible ureteroscopy. I've got a couple of questions linked to each other. First of all, the robotic flexible ureteroscopy, even though it will have a lot of feature potential, I think it is probably not taken up widely because of the cost and availability of the technology. So do we think that it can change how things are done? For example, fragmentation and suction, could it make it better? And if for people who are not doing the robotic flexible ureteroscopy, ergonomically, non-robotic, say, who are doing the traditional flexible ureteroscopy, how can we improve ergonomics to make sure that you don't have shoulder pain, neck pain, and so on, especially if you're wearing the lead gown for the whole day for a number of cases?
Now, I must say that the solution is the robot, because you are there away. You don't need to protect yourself because you are far away. You are even protected by the device. Today, my daughter was working it and she did it for the first time. And she's able, of course, to do flexible ureteroscopy. And she was very easy to learn for her. And so I think if you have a stone center, and I discussed this with Thorsten Bach in Germany now, probably they will try to get some. The cost, I agree with you, is a limiting factor. And as I mentioned, the reimbursement is not in line with it. If you would have the same reimbursement like for PCNL, it would be much easier. But of course, might be a problem. We had the same problem with the Da Vinci years ago. And now the DRG coming up because more people are using it, and therefore the calculation hospitals are included. So this could be a slow way, but I agree with you. Cost is an issue. What I would say, let's say you don't want to have a robot. I mentioned sitting is a very important thing because you can do it. I'm in favor of sitting. I know even if I place a double J stand, and I know some of my colleagues, they are always standing, and Thomas Knoll is always standing, and they want to do this. I don't feel this because
I like to sit down, all the time.
I think this is a very important thing, and I must say, when we presented our first study on RoboFlex in European urology, one of the discussion came back from the reviewers. They said, "Yes, I'm sitting. You see, I do the same thing." And so I think I agree. This is something you can improve. And I must say it will be very interesting now with this Wolf device, how this will work in a sitting position. This cannot be used by the robot because it's a totally different concept. So they would have to develop a new handle for this instrument because it's different. And so this will be probably an interesting device. One hope, and I must say, I was at the GU surgeon meeting, and Desai Mahesh was presenting a study comparing Moses technology with the TFL, and said this is equal. I don't think that it's equal. Since we have the Olympus device, we could cut down our laser times tremendously. And I think we are just learning with the device. And you know, Olivier reported the same thing in Patras when we had the course. And I must really echo this with our experience that we have now. And this, of course, also is in favor of shortening the operating time, let's say, even in a classical way. So I would really say, if you want to focus, look at the new devices, what they have, and probably also at a good laser.
Jens, a comment about the sitting position. I'm doing everything on while sitting, honestly. My only concern by looking back is about sitting is that it may increase the radiation exposure, but we don't have major calculations on that. So this is only one concern. This is a comment. I have a question about the robot, though. Do you think what is going to be the next step? Do you think that you will be able to manipulate the basket from away and do not have an assistant? Is this possible? Because this will change. I think the most ergonomic thing with the robot is that you don't expose yourself to radiation. But this should go also for the assistant. Eh? Is it possible? I don't know. I don't have experience.
It's an interesting question. I must say I don't see it at the moment because you know you need anyway someone who inserts the device as a like, and you know we know it from Da Vinci. We have a clipper, and we have this automated clipper.
Yep.
We don't use it normally. You know it's there.
Yeah, definitely.
Really used. So we still rely on our assistant to come in and put the clip. And a little bit, it's like this. So you need anyhow someone at the table. And so I would not see that this is a main thing. The other question would be whether you can compensate for respiratory movement. But I must say we are more using the respiratory movement now because we can fine tune the position of the laser fiber so that it's sometimes useful to have it. And the way it could be theoretically that the movement of the scope would really go with the respiratory movement. But this is not so easy. It's a very complicated way to do this. So I must say at the moment, I'm quite happy with the device as it is. I don't think, you know, that Johnson comes with the Monarch system and they are using it with a joystick. I must say, I don't think that you could do flexible.
Hence, last but not least, we are running out of time. But this is, I think it may be an interesting question. In your own clinical practice, what is the percentage of the flexibles with the robot, and what is the percentage of you taught us the flexible ureteroscopy all these years. So, are you doing any conventional flexible ureteroscopies anymore or not?
For the very small stones, let's say if you have an upper ureteral stone and it flushes up, then I change directly and I don't dock the robot. But for the real bigger stones, as let's say it starts at 8 millimeters higher up, we always dock the robot because there are no extra costs. It's just the coverage, so it's not a big cost.
It's nothing actually. I mean, the actual cost is the percentage of the cost. Baska?
No, thank you very much. Over to you, Andreas, for the next speaker.
So I think I will let Amelia Pietro Paolo. We are very pleased that Amelia is with us for the next talk, which is the additional disposable procedural requirements. And if there is any new, Amelia, please.
Thank you very much, Andreas. I'm very pleased to be here with you today. And I'm going to share my screen now to discuss about this interesting topic. So my topic today is about disposable equipment and what's new about it. So I hope you can see my screen. My name is Amelia Pietro Paolo. I work in a University Hospital Southampton as an endourologist, and these are my conflict of interest. So disposable equipment are actually our indispensable work tools, so we can't make without them. And what are they actually? So as we discussed before, there are guide wires, retrieval devices, access sheets, suction devices, laser fibers, ureteric stents, and irrigation devices. We're going to try to go through each of them and see what's new in each of them. As you know, the guide wires is our basic and we need them all the time. There are different types of guide wires and their characteristics can go through trackability, flexibility, diameter, type of tip, coatings or length, and also the material can be different. There is not much new about it in the last few years, but actually everybody has his own preference in terms of guide wires, and our own preference normally is having something hydrophilic and flexible enough, but also to give support and stability. Next, indispensable device are the retrieval devices, baskets. They have different characteristics. They differ for size, wire numbers or tip, or the way they open. And there are many news in this topic, but how do we choose the right retrieval device? So mainly about usability, cost is very important, the personal relationship with the company, but also the comfort of use, the influence of social media, as we've seen recently, the outcomes in our patients, but also the contract that we got with a specific company. There are many differences in basket. They differ in length, in size, in diameter, but mainly they need to be small enough to fit in a 3.6 French working channel of flexible ureteroscope and possibly being flexible enough to allow us to get a good degree bend to retrieve also the more difficult stones in the worse angle lower pole. So they're made mainly on nitinols, as we all know, and they have different shapes and different purposes. But actually, despite having different names and different brands, they all have the same concept. And as you can see, the purpose of them is all the same. So retrieval of smaller or larger baskets. But what's new? This is a new basket that is actually smaller than the others, is 1.9 French, and has the characteristic to be laser compatible. That means that can be small enough to fit together with the laser fiber in the working channel, our flexible ureteroscope, and allow us to, at the same time, grab and laser the stone, which I thought was quite interesting. Encompass is very well known for its capacity to remove at the same time multiple small fragments with this parachute concept and effect. And this can save time in case of multiple stone fragments that otherwise they would have been removed singularly. And as we discussed before, Empower is a new advantage introduced by Boston Scientific. And in few movements, this can be attached to the LithoView scope and can allow the surgeon to manipulate the stone on his own with no need of the help of the scrub nurse. Of course, using the same company can also cause disadvantages. And clearly, we can see they were not open enough to innovation. They were not simulated to change. There is not enough networking with reps of different companies, and no cost effective. And also our outcomes will be biased. So it's very important to look around what's on the markets. And about access sheet, we again are very important disposable devices in our clinical practice. We can see that over the years they've improved in flexibility, they became more hydrophilic and more cost effective. And also the more they improve, the more they can help us to improve our outcomes, as we've demonstrated with this paper. Suction devices can be actually one of the news in the last few years. These are suction devices introduced by the Chinese team in the rigid and semi-rigid ureteroscopes, and they use a negative pressure to help to speed up the suctioning of the small fragments. And a similar thing has been introduced for flexible ureteroscopes, again from the Chinese group. And the first one is a suctioning access sheath that is connected to a vacuum device. The second one is an intelligent control for the renal pelvic pressure that is connected again to an access sheath and a suctioning platform. their outcomes looks pretty good and their efficacy and safety as well. However, they've not still been spread in the endourology community much, and that's probably because the papers who they've been described have got low level of evidence, and so we need better randomized control trial to make sure they are really safe as they look like. This is opposite to instead what happens to PCNL, where in mini PCNL there is a very good suction devices, which is the clear Petra, which allows to, through a very small sheath, to suction in a continuous aspiration small fragments and dust in order to increase the visibility. And the results are very good. What is new in terms of laser fiber? As we know, thulium is the new kid on the block, as Dimitri will show us later. And as it has been demonstrated, this increased the speed of the fragmentation and the dusting, also decreased the size of the dust particles, and decreased the retropulsion thanks to the low energy pulse, and also the fiber itself is smaller, but also the device is a machine much smaller comparing it to the Holmium laser, and more interestingly, is less noisy. Moses laser is known to be an innovation in the last few years. And this is a mid-power Moses laser. It uses a Moses technology, but it's not such higher power as the 120, 200 watt, which are more famous. But actually we found that using a mid-power laser can still achieve good outcomes and much better than a smaller power laser. We use ureteric stents daily for our practice, and over the time they're evolving new properties. For example, they can reduce encrustation, or they are more firm against external compression. They also have the ability to inject contrast through them, and the coils can be more soft in order to decrease the bladder irritation. Many devices have been introduced also to facilitate the stent removal, for example, the magnetic double J stents. And these are, for example, some silicone endpiece that are connected to the distal bladder coil to reduce the irritation in cancer patients. Very good innovation is this biodegradable ureteric stent, which hopefully will have a bright future because it has 100% of degradability in urine within 10 days, but we don't have much data about it yet. Tumor stents are well known and they're not very new actually, but their material is still very widely used every time that the normal double J stent fails, for example, for extrinsic cancer or compression or strictures. If this also fails, the next step would be to use one of these new devices. These are different materials, and they are resonance stents made of metal, memocath, or allium. Which one is the best between the three? They're actually all good, and this paper has demonstrated that all these three devices can be useful in benign and malignant ureteric obstruction long term. The news in terms of double J stent and material is actually the J-fill. This is a normal double J stent, but at the end it's got a surgical thread, which is the one that will end up in the bladder. And thanks to this, will minimize the bladder irritation and can be equally removed with a normal grasper through the cystoscope. Of course, this can't be used for stones in the lower ureter, but it's got a good potential for the future. Ureteric stent materials have been evolving over the time, but actually there have been few studies that have shown that silicone stents are better for symptom control and for better quality of life of our patient. And as my colleague Thomas Tallis has also shown to have less incrustation over the time. And last but not least, irrigation devices. They've been trials, and in particular because we always want to reduce the intrarenal pressure and reduce our post-operative complication. And many of these has been described as mentioned before, a manual irrigation system through pedal or also gravity. Which one is the best is still not being clearly proven. But one of the new introduction in the market is the irrigation device EndoFlow or TraxairFlow by Rockmed. This is able to stabilize and create a steady liquid flow during the irrigation, and also can allow to indicate the pressure on the machine, which is identical to the one of the closed cavity. So what's next in endourology? Of course, our discipline has got a bright future. And as we said before, probably artificial intelligence is the next step for stone visualization and clearance, but also monitoring temperature and pressure in the kidney real time would be the next challenge to improve patient safety. Equally, to identify the stone real time would be paramount. And we know that there are many improvements in terms of lithotripsy with burst lithotripsy. And we are waiting to have more evidence in terms of suction that can improve our fragment retrieval and irrigation. And that's an example of how much our discipline has been quickly developing over the last few years, and has gone to a level that now we're just waiting to see what the future is preparing for us. Thank you very much, and please, I'm happy for any question.
Thanks, Amelia. That was a wonderful presentation. Just wanted to ask one question before handing over to Andreas. You know, you have a lot of companies making similar products and some companies making unique products. When it's a unique product, it's easier because if that's the only company making, you know it. How do you choose a product when, for example, stents or sheets, when different companies are making the same thing? How would you choose it? What is for people who are listening?
Well, good question. That's very the difficult part. We need to balance many things. And as I mentioned before, the cost and price is very important, mainly for our department. And we should balance probably the cost with the usability, the maneuverability of the equipment, and also I think doing hands-on or doing trials of the equipment is very important to choose which one is best in every case, and probably having more than one available could allow to choose which one to use in every single clinical scenarios.
Thank you.
Amelia, excellent presentation as expected, actually. I have two questions. They are not mine. They are coming from our audience. And I think that the first question is, what is the incidence, if there is any, of a ureteric injury by using negative suctioning device compared to standard suctioning device? If you know any, because honestly, I cannot see, I mean, in the literature, I cannot see any difference at all. But if you have reviewed the topic, so you have the expertise.
Exactly. As mentioned, the papers that we can analyze so far, they don't report major complication using suction device. But again, they are low level of evidence papers, and it would be good to compare the two, so with and without suction, in bigger randomized trial and see really what are the long-term complications. But I don't know of any.
Fair enough. And the other question from our colleagues is, what about antibiotic-coated stents? Antibiotic-coated stents. Is there anything new on that? Do we still use it or not anymore?
At the moment, I couldn't find there any news in this sense. I know that they were used and there were some talk about improving their use in the last few years, but I think they've been there are other ideas rather than covering with antibiotics, probably more hydrophilic coating or that will prevent the biofilms. are demonstrated to have a longer term efficacy rather than covering with antibiotics.
So I think, Andreas, there's
Sorry?
some work on silver nitrate coated. Amelia is right. There's some work on silver nitrate coating to reduce biofilm, because that is much more important than the
Yep.
antibiotic itself.
Exactly. And Amelia, I think we have some more time. Just one very quick question. I mean, to extend the question of the comment of the question of Pasca. You bombed us with, I mean, not you, I mean, the market is really bombed us with every day with a lot of materials. And since the time I was trained by Jens, let's say, I have seen a lot of disposables coming in and then going out. So I mean, in regards of increasing the stone-free rate and decreasing the complications, which one of these products that you showed us, you think, I mean, it's an objective, subjective idea. I mean, which one you think they would stood the test of time? What is your personal opinion? I mean, because we are seeing every day from a lot of companies the same, but a lot of products out there.
Yeah, I think some of them are really indispensable, so we cannot replace them. And for example, starting from the beginning of the procedure, I think guide wires, for example, sensor guide wire with a flexible tip and a more solid body is very important to start the procedure. And then I think in the retrieval device, for example, a zero tip basket, whatever brand this belongs to, is the best one to make sure we can grab our stone, whatever it is, because even if there are small fragments, then it will take longer, but it will still allow us to achieve the stone-free rate. And I can see in terms of fragmentation, a laser, thulium laser fiber is achieving very good outcomes. So I still don't have a personal experience on that. And I think the holmium still has a good place, but probably it would be interesting to know if thulium can completely replace holmium in the next few years. And for the access sheath, I find it very, very useful using access sheath in most of the intrarenal surgeries. And the brand, again, and the size, it all depends on the case and on the contracts that is stipulated with the hospital. But I would suggest anybody to have a good amount of access sheath ready. And for irrigation, to be honest, is very important to prevent complication. So from my suggestion is to use gravity irrigation and then a pump that can be controlled constantly. And that's in general for a global conduction of the procedure.
Thank you so much, Amelia. There are so many questions for you, actually. So please try to type your answer to as many as you can. Baska, please.
Sorry, Jens has a comment. Yeah, Jens,
please, Jens. Jens,
you're on mute, Jens.
I have one comment. And according to the doniers, as baskets, because you had domia baskets, because you were said, okay, tipless and so on. I'm very much in favor of the N-gauge. Why? Because I can open it. And I guess this is a problem. It's not a problem when you use an access sheath, because usually this is not a problem. But we have had in the ureter with domias bad experiences, at least myself. Did a valse, a ureter, and so, and I was taking the stone down. So I think it's very important that you have also in the armamentarium something that you can open, a grasp and open. I guess this is very important.
Thank you.
Thank you very much, Jens. Thank you, Amelia. That was wonderful. There are a few questions if you can go to the chat line for us. The next speaker is Dr. Enikev, and I'm really looking forward to this, Dimitri, with your different energy sources. So over to you.
Thank you, Kashkar. Thank you. Good evening, everybody. Just a second. So, dear colleagues, today I would like to shed some light on new energy sources in the endoscopic stone treatment. I have no conflicts of interest to declare. Currently, we cannot imagine urology without lasers. We use them for BPH, different cancers, but today I would like to mostly focus on lithotripsy. At the beginning, I would like to discuss how lasers work, and I have to go into physics, but I will try to explain it in simple terms. The basic principles of all lasers is always the same. A light source pumps energy into the crystal between two mirrors. Then the energy increases and one mirror is opened and a laser beam appears and goes to the fiber. While the mechanism is the same, lasers differ in their crystals. Each crystal gives its own wavelength. The wavelength determines whether energy is absorbed by water or hemoglobin. For example, the wavelengths of such crystals as KTP in the green light laser and neodymium allow for absorption in hemoglobin. So they're ineffective against stones because there is no hemoglobin. So conversely, thulium's and holmium's energy is absorbed by water, and a bit later I will explain why. Another important point is operation mode. It can be continuous when energy hits the target and pulsed when it fires intermittently. This is what we need for lithotripsy. So what makes lithotripsy possible and why do we need energies that are absorbed by water? To answer this, we need to know the composition of the stone. As you can see in this picture of the real kidney stone, it contains many pores and there is a water inside them. So what happens during lithotripsy? Actually, everything is quite simple. There are two mechanisms of action, thermal and mechanical. At first, the laser beam hits the stone surface and the water inside. Then heat changes the structure of the stone, which becomes brittle, and the mechanical effect destroys the stone. That's it. The next important aspect we should discuss is pulse duration. Now in modern lasers, you may choose which pulse to use for lithotripsy, long or short. A short pulse lasts up to 600 microseconds, long more than 1000. Long pulse is better in terms of retropulsion and fiber burn back, while the efficacy is the same. Having appeared more than 25 years ago, holmium-YAG laser quickly became the king of lithotripsy. However, as time goes by, we want more and more from our equipment. And what we want, first of all, in the era when endoscopes are becoming smaller and smaller, we need laser fibers that would fit them. And of course, we want it to be more effective and to have less retropulsion. Possible solution for that is pulse modulation. We are going to briefly talk about it. I would like to pay special attention to the frequently discussed Moses effect. A laser without Moses makes a single pulse which travels through the vapor tunnel. And a laser with a Moses effect at first makes a short pulse, which creates the vapor tunnel, and then the second long pulse, which destroys the stone. The developers of this technology say it decreases retropulsion. An in vitro study by El-Hilali showed less retropulsion and more effective dusting. A fresh in vivo experiment from Canada has confirmed these findings. A group from United Kingdom, headed by Professor Samani, showed better stone flow rate during ureteroscopy, but of course, we need more data. Besides the Moses effect by Luminis, there is another pulse modulation technology for holmium, such as vapor tunnel by Quanta system. There is a recent study from the University of Florida comparing the vapor tunnel with Moses. Results showed that at distance less than 1 millimeter, they are comparable, and at higher distance, Moses has some superior. Using lasers in clinical practice, we were interested to learn more about physical aspects. For that reason, together with physicists, several years ago, we organized a laser tech lab in a section of university, in our university, where we made different experiments with different lasers. It was really interesting for us. And as a result of this collaboration, we had a new thulium fiber laser And one of its key properties is its wavelength. It is 1.94 micrometers, and it matches the peak of water absorption. Water is the major tissue component that absorbs laser energy. And for example, the holmium yak laser's wavelength is significantly off the peak. So currently in Russia, I think it will be interesting for you. Currently in Russia, there are 3 models of thulium fiber lasers. So the first one, thulium fiber U1, is a device with a peak power 100 watt. It works in pulsed quasi-continuous mode and has excellent cutting properties. The second, thulium fiber U2, is a super pulse laser with a peak power of 500 watt and average power of 40 watts. So this device works in super pulse mode and it is good for lithotripsy. At the same time, its cutting properties are worse and we can compare it with holmium. And finally, we had U3, which combines the advantages of U1 and U2, and you can work in both pulse quasi-continuous mode and super pulse mode. I think, yes, here you may see the difference of quasi-continuous and super pulse modes on stone. The quasi-continuous ablation is rather limited with extensive chairing, whereas the super pulse ablation effectively burns stone with no chairing at all. So here you may see it. So you can clearly see the difference. So thulium fiber laser U3 combining with continuous mode and super pulse modes became a prototype for other thulium fiber lasers all over the world. To understand this technology, I think it's better to compare it with well-known holmium device. The holmium yak device combines output of several flash lamp pump holmium yak crystal lasers into one surgical fiber. As for the thulium fiber laser, it is different in this regard. It uses about 30 meters of thulium fiber, which is pumped by a diode laser as a laser source. Another important difference of this technology is the cooling system. So thulium fiber laser uses air cooling in contrast to all other lasers that use water cooling. So all this makes it lighter, more compact, and yes, and it's really works quieter. Yes, so we decided to compare these lasers in vitro. For that, we use especially first for, of course, for lithotripsy. For that, we used a specially designed cuvette with 1 millimeter mesh on the bottom. We put it into another cuvette and filled it with water. In the inner cuvette, we put a stone and introduced a laser fiber. This setup allowed us to estimate speed of stone ablation. We use energy from 0.5 joule to 1.5 joule and power of 15 to 30 watts. Here it is. Here is the video, how it was. So our preclinical study showed that thulium fiber was twice as effective in fragmentation at high pulse rate and in dusting. Also, we were interested in retropulsion. For that, we used a chamber with 2 rulers at the bottom. The chamber was filled with water and the stone was placed between 2 rulers and a single pulse was fired. And all the process we recorded with a high-speed camera. And we found that retropulsion with thulium fiber laser was 2 times less than with holmium. Further comparison by Professor Traxel also confirmed less retropulsion even with a Moses effect, So the goal of one of our latest studies was to compare temperature changes during lithotripsy. For that, we used the same setup as at the first experiment. We put the thermocouples into the inner cuvette, close to the stone, into the outer cuvette, and into the inflow and outflow tubes. We found that there is no differences in temperature changes. So currently there are several ongoing clinical trials on thulium fiber lithotripsy. Some of them have already been published. It was shown that thulium fiber effective in all stone densities. Stone-free rate in ureteroscopy is 89%, and in PCNL is about 85%. just a few words about perspectives. Laser fibers. So for holmium YAG laser, 200 micrometers is the minimum we can get due to its technology. Thulium fiber laser allows for smaller, even to 70 micrometers. So now we have 150. First results showed same safety and retropulsion with the potential of smaller dust with using smaller fiber. Summing up, holmium laser remains one of the best tools available for lithotripsy, as the MOSES technology promises decreased retropulsion and increased efficacy. Thulium fiber laser has shown high efficacy and safety in preclinical trials. The first clinical studies are also revealed the same for ureteroscopy and PCNL. However, of course, we need more RCT to prove it in future. So thank you very much for your attention.
Thank you.
So, Dimitri, thank you very much for an excellent presentation. But I think you and your whole team should really be congratulated on the project that you are doing all these years about the TFL. Really, really, you are pioneering something, I mean, experimentally, but I think it will be also, it will make probably a difference in our clinical practice. One question for me, we don't have any questions from you, from the audiences yet. The expectations of the TFL based on the in vitro studies were really sky high. We were expecting to see something real different. And to speak a word of the devil, the first clinical use, I don't think, and we have a panel, an expert panel actually to discuss, I haven't seen such a huge, I'm not an expert on the TFL, of course, but I'm not 100% sure that we have really achieved what it was expected. That's the words of the devil. I think what you have done already, when the diode laser was in the market, the problem was, I mean, the wall plug efficiency of the diode lasers, where it was extremely better and higher compared to any other laser. The problem with the diode laser out there was the fiber, actually. They were not able to create it, and Jens, please comment on that. So you have done with the air cooling and the water plug efficiency is very high with TFL, and you came with a very small device. It will be more economical. I think that it really makes a difference. But give me your clinical practice. I need to hear a lot more about your clinical practice. And I know that you will give us your clinical experience. And I want the experience of others also. Bhaskar, Jens, and Thomas, please, Amelia. But Dimitri, please comment.
Yes, Andres, thank you for your question. It's really very, nowadays it's hot topic. So first of all, we should understand that this is absolutely another device, not the thulium YAG device. So it's absolutely another technology with another wavelength. So we use thulium fiber last 4 years. So first of all, of course, we use it for lithotripsy. After preclinical trials, we use it for endoscopic enucleation of prostates. So we see that is less chairing, that is effective cutting tool with less carbonization. We use it for en-bloc resection of non-muscle invasive bladder cancer. So it's also, we see all the advantages because there is no burning of the tissue, and at the same time, we can clearly see all the layers. We can clearly see the muscle layer and detect the tumor. And we also use it in different strictures with different localizations. So ureteral stricture, ureteral stricture. So now it's we see the advantages of this technology, but of course we have clinical trials of already. We have published some of them, but of course we need more clinical trials, randomized clinical trials, more data to prove its efficacy, and of course it will take some time for all of us.
Jens, please. Sorry, Baska. Jens,
No, it's okay. Jens, please, after you.
Okay. We have the device now for only, I think, the last 2 months, 3 months, because we were able, our thulium YAG laser was not working anymore, so I was able to replace it by the thulium fiber laser. This was quite nice.
Good.
So I have experience also with enucleation. I must say here, I still like the holmium better because it's still a kind of chairing. It's not completely the same like a holmium fiber, which I liked for the enucleation. You can use it, you can do it, we did it, but I really think the Luminis is better in this regard for the enucleation of a prostate, because I see the layers much better. But for stones, I think it's really a new world for us. But maybe I can ask Dimitri, because we get from the company now a certain setting. They say dusting weak stone, dusting hard stone, and so on. So what we get presets. Can you help us a little bit? Because Olivier was also mentioning, and we have sometimes, is that you are starting then the stone fragments very easily, and then you get this jacuzzi effect immediately. With a holmium laser, we needed to change something. Now this goes continuously. Do you have some secrets concerning energy and frequency, like we know it from the holmium laser?
Thank you for your comments. So first of all, about enucleation. So we have a rather big experience with holmium YAG laser for enucleation, with electroenucleation, and now we mostly use thulium fiber and use holmium only for randomized prospective randomized control studies. Of course, what is really very important is our settings. So it depends upon the experience. Of course, it depends upon your speed of your incisions, and depends upon the settings. So if you start working with a new laser, with a new technology, of course, I always recommend to lower the settings. So I recommend, if we talk about soft tissues, about BPH, I recommend to lower the energy from 60 to 30 watts. Use 1.5 joule and 30 watts. So with these settings, you will you move slower, and of course the carbonization will be less, and you will clearly see all the layers. So it will be easier. For bladder cancer, the settings are always the same. It's 1.0 joule, and it's 10 watts. So this is optimal for working on the bladder. And I think as we talk for the stones, we have a paper we published in, if I'm not mistaken, in Journal of Endourology some time ago, in there, and all the secrets are there. But I think that we should always change the settings and control. It depends on your personal experience, and I think the same with holmium and the same with thulium fiber laser. So the settings that are recommended by the manufacturer, they are optimal, but of course during your own experience you will feel it, and you will do it, I think, in the best way.
Thanks, Dimitri. Can I ask you something? So you've obviously done a lot of work on lasers and now on TFL. What I wanted to ask is, there are definitely advantage with TFL, especially with portability. It is lightweight, and so on. The initially when it came in, people were talking about frequency. It's super fast, it goes at 2000, 500, 100. Now we know that if you go at a high frequency, it has a lot of digital interference, with the digital scopes. Do you think that frequency, and if you go very high frequency, you have to lower the power quite a bit. Do you think somewhere for softer stones, it is absolutely fine? For really hard stones, that the difference between the holmium and thulium may not be as much? What is your experience?
Well, I think the experience showed that it is possible, and 200 hertz is as much as we need.
And does it make a difference into the interference? For the digital scopes, is there a lot of interference when you go fast?
No, Bashar, there is no difference, so we don't see any difference.
Okay. Thank you very much. We have one question in the. Can you please simply explain? So you have explained it, Dimitri, but this is the question. In a very simple words, what is the difference between thulium YAG and TFL?
Well, first of all, absolutely two different technology. I tried to explain it very in simple terms during presentation. So absolutely different technology, air cooling and water cooling. So it's lighter and more compact and easier, and there's not so much noise. But the main point is the wavelength of this laser. So, and this wavelength allows us to make very precise, delicate incision with, if we talk about about soft tissues, very delicate incisions with less carbonization effect. And if we talk about stones, in stones, it's possible to use in stones because there was for a long time there was absolute stereotype that thulium YAG we cannot use in stones. Thulium fiber we can use in stones, both in soft tissues and in stones. And in stones we have first very good results in lithotripsy in its efficacy and less retropulsion.
Thank you very much. Andreas, over to you.
Well, I think just to conclude, just a comment for the question that we had from the audience, and of course the technology is by far different. But the thulium YAG laser is like the holmium YAG laser. You have a source for the light production, and then you have the transmission on the machine, and then you have to have some cooling system on the machine. The TFL actually, I mean, it's not like that, but imagine that you have in the thulium YAG laser, you have not only the thulium part, but you have the aluminum garnet and the crystals inside. While inside the TFL fiber, you have only the thulium crystals that they actually transmit the fiber. And guys, and Dimitri, correct me if I'm wrong, as Jens is showing with his finger. So that is, I think, the major difference, at least to me. I'm not an expert on TFL. So I would say, to conclude, because we are a little bit ahead of the time, first of all, I would like to really thank every one of you that you are here listening to us or seeing us tonight, because without you, it's impossible to do such courses. Of course, to thank the esteemed faculty that we have with us and my co-moderator, actually. And I would say, as a final comment, that new technologies are very important, not only for the young residents and the young urologists, but for everybody. The technology is evolving so heavily in urology, the surgical technology, that it's very easy to left behind for everyone of us. So we should inform ourselves and keep up with technology. So thank you very much, everybody, for being here, and I hope that you enjoyed.
And thank you to the EASU team as well. Thank you.
Of course, definitely.
Thank you
and
very
also
much.
to the EAU and ESU ladies who actually make everything real, and for us to be here. Thank you very much, everybody.
Bye-bye.
Thank you.
Bye-bye.
Bye.
Thank you very much. Bye.
Bye.